There is an extra piece of information which I missed before the calculation. The way this book is written is unfortunately saying things. It says that there are many things that one should verify, and I cannot. So, it says that this bracket is the one induced by the following Poisson structure. Okay? So, there are many things that he claims without proof. So, claims. So the first claim is an obvious thing, that this is bracket on G star. Hence, gives me a delta on G. Second thing is that the bracket on G and this delta give Lie by algebra structure to this G. Sorry, to the algebra, sorry. I mean, the fact this is a bracket is really totally obvious in the sense that it's just a calculation. It's a trivial calculation. You have to check various things and to manipulate this. I've done even a piece of the check just to see if you can do it, but you can do it. Now, the fact that this gives a by algebra structure is more elaborate calculation because you have to construct the dual of this, right? So it's more complicated. But then there is a third claim, which is really terrible. We know by the Drinfeld theorem that any by algebra on G, by algebra structure on G, corresponds to Poisson structure on the group. And he gives this Poisson structure. So he says that corresponding Poisson structure, that we know it exists by this theorem, on G, by Drinfeld theorem, is as follows. So I'm writing this Poisson structure, and what I'm going to do is to see what the Poisson structure is for SL2. This is all I'm doing, not verifying this. Well, you could verify this for what is in SL2, but this is not what I'm doing. This is really trivial, this verification for SL2. But this is not what I'm doing. It's more complicated. It's the following. It's very nice. I like it. So the Poisson structure is this. First of all, I need to define two operators, which I personally denote in a different way, but he denotes it in this horrible way. So he defines the gradient of f is not the gradient. This is an action of the universal enveloping algebra on the space of functions. It's very unpleasant to write it in this way. But let's bear with him. So this is an element in G. This is a function of the group. This is the pairing defining this symbol. This by definition is the, I think I already defined it at some point, but let's do it again. This action is very important. It is extremely important. It holds the key to the representation theory of these things. Why am I saying this is very important? Because if one has enough determination, can check that this pairing tells me the action of this. This is the action of the vector field x on the functions. It's exactly this action. So G are the left invariant vector fields. Vector fields act on functions. This is the action when you take the element to be the identity, this is exactly the action of the vector field. I know it doesn't look like, but it is. So this is really x, no, he calls it psi, very regardless of the fact that anyone in the world defines with Greek letters the dual, he uses Greek letters for G, psi times f. This is the action. This is very important because this will give rise to action of universal enveloping algebra. This action is an infinite dimensional vector space. It's very important, this action. I'm studying action of groups that have applications in physics. This is an extremely important, there's a different way of denote this, because this is called the, one is the delta action, the other is the L action. One is on the right, the other on the left, I forget. The other one is the obvious other one. So x goes on the other side. Right. So x is in the part of the argument. So I'm saying that this looks very strange, but it is nothing but the usual actions on the right and on the left. Given this, what is this Poisson? So Poisson is 1/2 so this is an element on the dual because it's applied to an element on G. So this is R of, I forget, so it is delta prime F1 plus, no, minus. And this is the bilinear form identifying G and G star, okay? So this is the pairing of the bilinear form. And wait, what am I saying? No, wrong. This is, I need this. So here there is a big confusion between pairing and the scalar product, right? Everything all together with happiness. So it's and the other is the other one. R delta F1 I made the calculation, okay? At least because I felt that these actions are very interesting, so they were worth at least the effort to show that this terrible exposition hides important facts about actions of the algebra over functions, okay? And for Nicoletta, this is the Poisson bracket coming from quantum groups. If you take the usual R matrix, if R is your R matrix, Yes, but if you take the usual R matrix, the one that gives you SL2Q,
yes,
it's the same, except that if you do it in this way, it's coming out with much less effort than this way. So I don't know what the guy's doing, I really don't. And it's the standard Poisson structure on SL2. Oops. So are we ready for this very, what can I say, very...
So the big brackets are the
pairing, hopefully.
giving form on the dual?
No, see? That's a very good question. So he says, I want a pairing, okay? But he doesn't take the cation killing. In the example, he takes the trace pairing, okay? So let's make the example. Because all of this will hold...
This is a number, it's not a function.
It is a function. Because if you... Why don't we do the calculation so it will be clear, okay? So I think that
Oh yes, because that.
let's make the calculation, it will be clear.
Yes.
I'm happy you say yes, but let's make the
Yes,
calculation.
I see that it's not a number because you have to apply afterwards this F2 and F1 to an element in G.
It's very obscure, this definition. Only when I made the calculation I understood what it's doing. Okay, so let us make this little thing. No, but the truth is that if I hadn't already known what this is, what the R matrix is, what is the result of the Poisson bracket, I could have never done this calculation. That's why I'm questioning these notes, because this is ridiculous that you already have to know everything in order to recognize it in that textbook. This is absolutely ridiculous. So SL2. So he says, let's take this as our G. And this is the group. And then let's take, so this form, we take it as the trace of this. It's not a Cartan killing, it takes this. It's perfectly fine.
Xi and eta lie in G dual.
No, he uses Greek letter for G.
No, but there, when you use in the definition of the
In this
Poisson
definition?
bracket, no, in the definition of the Poisson bracket below that you gave,
Where?
there, in front of you, yes. So you use the
Yes, so psi is in G.
to,
So it's a pairing.
no, but below.
So
R goes from G star to G star.
R? Yes.
You
Okay.
have to apply
So
those
delta-
elements to an element in G.
In G.
So you have to.
So delta
So
prime
it's,
F2 is what?
okay, it's better.
F2 of X and of C. Yes.
So those are elements in G.
Mm-hmm.
Okay. So now psi and eta lie in G.
Yes. Yes.
Okay.
So this will give you a bilinear form in G, hence it will give you an identification between G and G star. Let's look at what is this nice exercise for those of us that already taught the course once or twice, because if one has not been a professor and this cannot make this calculation, so it's ridiculous. So let's see, no, I'm really angry because it's just ridiculous to write something in this way. So what is the identification that we make, okay, through this? So we're identifying SL2 with this dual. So if we take, I'm making the identification, right, because I will need it after, because this R goes back and forth, right? What is Nico?
F1 and F2
Are elements in the C infinity of G.
of the group.
Yes, yes. See, it's really, okay, so F I is in the C
So
infinity
psi
of
is
G.
in the group. So psi is in the group.
No?
If there are functions, so how can you apply a function on the group to an element which is not in the group?
Repeat the question, sorry.
When you define F1, F2, the Poisson bracket, and you apply
Ah, yes, yes.
The-
No,
the
no,
function
no.
on
No,
its
no.
side.
True. So what you want to do is let's see what it does. So F is I checked all this. No, so there is, how can I find this? Can we go through the exam? Because I checked all of this and now I don't know the answer. Wait, see. So this is really, no. So here's an X here, right? This is an X in the group, right?
Okay.
So this is the axis in here, I think, right? Because for each x, this is an element in the dual, right? Because it is paired with an element in G. So for a fixed x in the group, you get this pairing. When x is the identity, the pairing is the usual one. Is the pairing of left invariant acting on the, so here. Here is the correct. No, but Fabrizio said.
Then those are two elements in G dual.
Yes, there are two elements in G dual. But he happily moves between G and G dual through this identification.
Okay.
So you have a bilinear form that identifies G with G dual, but
No,
is a bilinear
fine.
in G and bilinear in G star.
But still you're not using, perhaps you're going to explain.
What?
Is
No,
that,
these
is that
identifiers.
just the evaluation? So you said that your objection is that both R delta prime and then delta prime of F2 are both in G dual.
Yeah.
I guess he's identifying one of them with its elements in G and then applying it to G, right?
But well, let's see the example. Maybe it's more clear, but I think it's... Okay, so it's really... If you want to compute, you really need to know what these things here go here. It's in, you have to. So, where does this go? So this will go to the function that takes a matrix, okay? So say ij is a matrix in SL2, and associate the trace, so this is psi ij dual, right? The trace of the matrix, I'm being very sloppy, you have to forgive me. Okay, let's take say psi. Okay, psi is a matrix. Okay. Where does the matrix psi go? It goes to the function psi star, taking the trace of A psi. No, psi, oh boy. So it's going to whatever. This is what it's doing. Now, if you make the calculation, you see that this will exchange the upper Borel with the lower Borel. So it's, if you take, say, this, do we trust me? So this takes x and takes psi and goes to psi transpose, in the sense that if you take, say, the matrix 0, psi 1, 2, 1, 0, 0, where does this go? It goes to the A, going to the trace of A11, A12, A21, A22. I'm sorry for this silly calculation. 0, psi 2, 1. So this becomes, see this...
Maybe it says on the left.
Psi
should be on the left.
Should be on the left. Thank you. Because already this does not come out. So you see that the trace of this will give contribution, so will be the trace, will be psi 21 A12, right? So this is psi 12 star in some sense, right? So it's this is a four-dimensional vector space. I'm looking at the element on the standard basis in the position 2, 1. Look, I get the element in the position 1, 2 here, because it's the, right? So this will be psi going to psi transpose in the dual. It's important because he uses this identification back and forth, so we need to know where these things are going, right? This is fundamental. This degree of happiness. This should be very well, this, right? Now we have to do that. So we have to compute this delta, and we have to compute this R. By R we know, let me write the R somewhere, okay? Well, I leave it written here. because we have to use arm. So we have to compute this, okay. I made the calculation in SLN, but let's, okay, so it's delta xij. Wonderful. What is this? So I call xij the coordinate function on SL2 that takes, so I have to make a, so x12 applied to a11, a12, a21, a22 gives me a12. Okay, it's the coordinate function, right? So it's xij will give me. So in SL2 we have the function. So this is my f, right? This is an element of the C infinity on SL2, the coordinate. There are global coordinates there. So I have to make this calculation, okay? What is, so this is x1ij, and this, I'm sorry, this is a for me, I apologize. I use x for the coordinate functions. I'm sorry, I didn't make a calculation. So this is the d dt in 0. Then I have to look at the aij term, sorry, the ij term of the following expansion. I have to make the exponential, so it is t of the matrix psi plus whatever, I don't care because I take the derivative, times a. And I have to look at the term ij of this, right? Obviously, what happens is that, see, all these terms do not contribute because I'm taking derivative 0. So I will get just the multiplication psi a, right? So it will be the summation of psi ik a kj. Right. And for delta prime is absolutely the same, except that a is on the other side. So the a, 1 plus t psi plus, so it will be summation over k, of course, psi, no, a I k psi kj. So we know. Are you happy? Because now we have to make this, we have to compute this now. All right. So okay. I don't know what I'm doing here. So I'm computing this. I'm computing. I've decided to compute just this. I'm sorry that it is so modest, because if we can do this, we can do everything. SL2. So this is so I apply this to A in order to make the calculation. Plus, no, minus 1/2 r is okay. So I'm a bit confused. How do I get matrices here? Ah, right. I've done this calculation a week ago, so I don't remember. So I just wrote what is written there here, right? So I can erase because this I already used. Now the result is coming out right, so I know that I made the correct calculation. So let us compute the this one here. So I computed the See, what is the problem is this. The calculation I'm going to make is the following, that R takes me from G star to G star, right? So, this is an element of G star, except that I really want to see it in terms of matrices, right? Because the only way I can write x plus minus x minus is using matrices formulation. You see what I have to do, right? For example, I'll make a stupid example. If I have this, say, A, B, C, right? No, minus A. Suppose I have this matrix. What is R doing to this matrix? This matrix is doing this. So it will C. It will, no, I can put, I don't need to do this. C minus. So the R applied to this will give me, what does it give me?
0B meno C.
0B, sì. 0B, 0, 0, minus 0, 0, C, 0. Okay? This is what it does to the matrix. So you give me the upper part minus the lower part.
This is the action on G, but on G star you have to transpose this. So you...
Yes, it's on G. Yes, I have to be more careful on the other.
On G star...
Yes. But I'm saying
Minus.
I wrote this because I wanted to say I need matrices to do this. I cannot write a just function. So I want to see the element of the dual, which is this x11, as a matrix, not just as a function. So I have to reconstruct it. And what does this x12 does? 11 does. So it takes. So it takes I'm sorry I'm doing like this, but you see I'm slow. So this takes me to we have it here, right? Takes me to the following function, psi, no, it's the prime, right? So it's A11 psi 11 plus A12 psi 21. You see, I made this calculation. So this corresponds to the following matrix. So it will be A11 because it's in this position, then you have A12, 0 minus A11. So this is the matrix associated to that. No? Nicoletta is now... No, but if you look at me like that, it's very bad. This is an element of the dual. So what does it do? Takes an element in G and spits out an element in C, right? But, devi scappare. No, mi dispiace.
No,
ma guarda, no,
lo farò.
Fabrizio, hai capito Marta?
No.
No, allora, la loro non lo chiedo neanche. I don't. No, it's very simple. You have. So suppose you have an element C4, right? C. So this you have a vector, say V1, V2, V3, V4, the coordinates. This is going to A1, V1 plus A2, V2 plus A3, V3 plus A4, V4. So if you identify C4 star with C, right? Then phi is the vector A1, A2, A3, A4. Right? C4, of course. This is all I'm doing. It's the usual identification through the standard basis. Except that here are matrices, big deal. This is first component, second component, third component, fourth component. I look, see, the first component is A11. Great, it means that A11 goes here. I made a mistake, of course. This is disastrous, right? Because A12 is, right? Because, let me check. Mi dispiace, sono una bestia. Sto vedendo tantissimo. Yes, I made a mistake because see, this is the position 1, 1, this is the position 2, 1. Cioè, hai capito cosa sta succedendo? So I'm writing a linear form identifying a vector space with its dual. Whereas the 2 by 2 matrices, it doesn't matter vector space calculation. I'm sorry, because this is like a placeholder. It's like 1, 1 position, 2, 1 position. And I look at the coefficient that is there.
Then I don't understand, because then you don't want simply a vector, you want a matrix, because you have minus A11.
Why do I have minus A11? Because this position is like you don't have it. Because SL2 is a C3, right? Because SL2 is all the matrices A, B, C minus A. So this one does not exist. So I care only about these 3, right, positions.
Yes, in the X you have not C.
I don't have psi 1, 2. So there is nothing, 0, because there is no psi 1, 2.
I mean, the parameters are 3 there.
There are, yes, there are 3, yes, absolutely, yes. This is minus, so this is really minus psi 1, 1, yes. Doesn't matter. It is. No, but the calculation has yet to start because we have to apply R to this. Do I have the right to be angry with you? No, but I figured, I have to be able to make this calculation because I do research on this topic, so I should be able to compute this strange bracket. That's all I feel. So I sat down and wrote it. It was not even too bad, but is that I do these things all day, so this is why I was doing it. So this sends psi 1, 1, psi 1, 2, psi 2, 1 minus psi 1, 1. Where does this send? Look at the same formula. So it is A1, 1 psi 1, 2 plus so it's 1, 1, 2 psi 2, 2, which is true, is minus psi 1, 1, doesn't matter. So this corresponds to A1, is 0, A1, 1, no, it's not 0, it's minus A1, 2, right? Sorry. So this is minus, disaster. It went into many pieces. So see, is minus A1, 2, and then you have A11, 0, A12. So this is the corresponding matrix. Same rule. Okay, so now you trust me for the others, which I have computed. So one computes also this. So I need to compute this one, which is applied to some matrix. So it's always A, right? So applied to some matrix A, this is same calculation. I wrote it somewhere. Where did I write it? I hate myself when this happens. A11, A21, 0 minus A11, So this is the delta 1, 1. The delta x 1, 2, which is 1, 2, a1, 1, a2, 2 minus a1, 1, 0. Wonderful. Then you do this formula, okay? So this formula says 1/2, and then you apply r to this, to x11. Where is x11? There. So it is paired with x12. And then the pairing, so this is R, right? Because if you apply R to this, this piece goes away, remains only this. That's,
Yes. And this is the positive part because of the transposition.
it is the positive part because of the transposition, thank you. I wrote it correctly here, but then I did not say it. Then there is a thing which does not contribute. Oh God. Why do I write?
Zero minus a to 1.
So 0 minus a to 1, thank you, is here. 0. But this part will give me 0 anyway. 0 minus a 1, 1. Now I have to compute the trace of this, right? So trace of this is 0, 0, so that is so if this thing is calculating the trace, so that is 1/2 a12 a11, because the trace of this, see, the only contribution is this times this. Now trace of this should be 0, right? It's always 0, so there's no contribution of this. This is the correct. Aren't you impressed? So professor, what do you think? Do I deserve a 30 lode in the Algebra Superiore? What do you think? You will give?
With academic kiss.
Eh?
With academic kiss. But the private.
No, be careful because sexual harassment. No, but I don't want to feel myself very smart. It's just a calculation. It's stupid. It's not that you are thinking, oh, the concept. It's very stupid because you identify SL2 with SL2 star and then you do all these derivatives. There is nothing to it. Except that is, for me at least, it's like a road that you don't have to miss any step in this road because at any moment you can make a mistake. But we agree, I mean, it's not smart, this calculation. It's just following the recipe. But I feel like you have to be able to do this, otherwise the theory is empty. If you speak about these formulas without calculation, I don't know. Maybe Marta, there is no time for you.
I think yes.
I'm so sorry.
No, it's okay. I really.
Because when he said, that, let's do this calculation, and then I knew. Vabbè. So I'm finished.